Hello students, today I will discuss with you about equation of plane. If one of the three things which are written over here given to you, you can easily find out equation of a plane. Number one, if normal to a plane is given and plane's perpendicular distance from origin is given, you can find out equation of plane. If a point on a plane and a vector which is perpendicular to plane is given, then also you can find out equation of plane. And the third thing is, if 3 points on the plane are given, then you can find out equation of plane. So today one by one I am going to tell you what equation, vector form and in the Cartesian form we can use or we can derive from these three conditions. First I will take this is called equation of a plane in normal form. So I am just going to take the first one. That is equation of plane in normal form. Equation of plane in normal form. This is what we are going to take today. Okay, so equation of plane. Now over here I'm just going to draw a plane for you. I'll draw three-dimensional plane over here, and then I'm taking one plane over here. Okay, so this is my x-axis over here, this is my x, say this is my y, and say this is my z, and this is my plane over here. Now what I'm going to do, this is O over here, and I can take one point over here on the plane, one point, say the point is P, and then I can take another point over here, which is, as I mentioned, that there is a vector a normal to a plane. So this ON is normal to a plane and this is the distance D, and OP has coordinates x, y and z, any point in the plane, and this OP can be over here, OP can be represented by R vector. Now this ON, there will be one n cap which is a normal vector, a unit vector ON is the unit vector along ON, which is going to represent direction of ON, and this is R over here. OP is R, so this is R over here, this is R over here. D is distance from this point. This D is the perpendicular distance between the plane and the origin. And if I have to find out equation of this plane, then though proof of this is not there, so I'm just going to write the equation directly, first in the vector form. That is going to be R vector dot n cap is equals to D. This is one of the equation which is called the vector equation of the plane. This is vector equation. If I simplify it, I am going to get two equation. One is called in the direction ratios. This equation is in the form of direction cosine Lx plus My plus Nz is equal to D. There is another equation which can be R vector is equals to AI plus BJ plus CK is equals to D, and this will give me another equation AX plus BY plus CZ is equal to D. So this is a vector form and this is Cartesian form. So same way, this is my Cartesian form of the vector. So this is the equation of, there are two equations over here, equation of a plane in the normal form when the distance between the origin and the plane is given, and normal to a plane, that ON is given, and over here n cap is unit vector along ON. Now I'm going to take the second equation over here, which is if a point on a plane is given, if any point on a plane is given, and a vector perpendicular to plane is given. In that case, how we are going to find out equation of the plane? So that I'll just show you right now over here on the next page. So what I'll do, again I'm going to plot a three-dimensional plane over here. Say this is my x, So this is my y over here, and over here I have z. Okay. Now what I'm going to do, I'll just take a plane, any plane I can take. So I'm just taking a plane over here in the space, and on this plane I will take a point as usual. Say this is P, which is normal, which is having coordinates as x, y, z, and then I will take another point. As I said, I'll take another point over here, say A. Now I'll just join it from the origin OA, and this I'll just join AP, and then OA is generally we represent it with R vector, so I'm just writing it R vector, and OA, which is a vector, is represented by say A vector. Now as I told that we have to take one perpendicular vector to plane also. So say I will consider another vector, and which is perpendicular, say this is n vector. Now over here this A is a given point. A will be a given point on the plane. This will be given to you, and n vector will be a perpendicular. N vector is perpendicular to the plane. Say plane is pi, so I'll just write this as n is perpendicular to pi. Now if you just see this AP vector, this A and P, AP vector is going to be perpendicular to n cap. So AP vector dot n cap should be equal to 0. So what will be AP vector? If I just take R and A over here and triangle law, I am going to get R minus A vector dot n vector is equals to 0. And when I am going to simplify it, I will get, this is my vector form. So this is my vector form. This is my vector form. If I am going to simplify it, if I'll simplify it, I am going to get an equation which is something like this: A into x minus x1 plus b into y minus y1 plus c into z minus z1 equals to 0. Now over here, what are x1, y1, z1? x1, y1 and z1 point A. And what are A, B, C over here? What are A, B, C are direction ratios of n vector. So this is the vector form, and this is going to be the Cartesian form. See, this is Cartesian form. So if two of the conditions, if these two things are given, that a point on plane is given and a vector perpendicular to the plane is given, so we can find out equation. Now the third case, when 3 points on the plane are given and we have to find out equation. So 3 points are given. Now we will take 3 points given on the plane and we are going to find out equation of it. So I will just tell you the vector form also. The proof is not there. The proof is not there in the syllabus, so we are not covering proof right now. So I'll just take 3 dimensions again, and then I'll create a plane over here. I'll take plane. Now there are 3 points. As usual, I'm taking P as a point which is there, which is always there on the plane, say x, y, z. So for it, this point coordinates are x, y, and z. Okay. So this P is x, y, z, and then there are 3 points, 3 other points are there, say R, say then there is S, and say then there is say another point T. Now if I just join, this is O origin, if I just join it, this is going to be my R vector, and then there are other 3 points, say R, S, and T are 3 points over here. Say this is given by A vector. If I join S also, so say this is my B vector, and if I join T, so say T, now there it should be straight line, but there's no place, I just joined it like that, so say this is C vector. So if I join RS and RT over here, and if I take cross product of these two, so I'm going to get a perpendicular vector. So RS vector dot RT vector will be a vector which is perpendicular to the plane. So now this RS cross RT is a vector which is perpendicular to the plane. So I'm just relating it to the case number 2, where one point is given and a perpendicular vector is also given to me. So what I'll do, I can just find out this vector equation. If I join this R and A, this thing I'll join. This is R, this line is R, this is A. So RP is a vector, so R minus A is a vector, and dot product of this with a perpendicular vector to plane. So dot product of this with RS and RT will be equal to 0. I have taken R as a point. Over here you can take S and T also over here, and you can just write down, answer will come always same. If I simplify, the vector equation comes something like this: R minus A dot. If I solve RS vector over here, RS vector, I am going to get B minus A. If I am going to solve RT vector, I am going to get C minus A is equals to 0. Now this is my vector form. If I simplify this equation, then I am going to find out a vector form, and vector form will come something like this: x minus x1, y minus y1, z minus z1. Then second row, this is kind of determinant: x2 minus x1, y2 minus y1, z2 minus z1. Then x3 minus x1, y3 minus y1, and z3 minus z1 equals to 0. So this is Cartesian form. This is Cartesian form of a plane passing through 3 points. So this, the first one, R minus A dot B minus A cross C minus A is equal to 0, is a vector form. So this is the vector form, and this is my Cartesian form. So this is how we can find out equation of a plane. There should be one of the 3 mentioned conditions should be given. Number 1, normal to plane and perpendicular distance of a plane from the origin should be given, or one point and a perpendicular vector should be given, or 3 points should be given. Then we can find out equation of plane.